right, so this is the last section for this week. There's 2 more after this to finish off the unit, and this is about solving some equations. Specifically, today we're going to talk about how to solve exponential equations. You are for sure going to need your calculator today as we're working, so please have that available. That way you can kind of work along with us and type things in with us so you kind of experience how your calculator works in these types of questions. All right, so here is kind of the first idea. So we have an equation, 2 to the x equals 2 to the 4th, and we want to figure out what does x equal. And so what you're looking at here is you're looking at an equation where you have 2 exponentials and they have the exact same base. They're both base 2. And so because they're both base 2, that means in order for these two to be equal, this exponent here has to be the same as this exponent there. They have to be the same because their bases are the same. So in this case, x has to be equal to 4. The same thing is true over here. We have 5 to the power of 2x equals 5 to the power of 6. Since they're both base 5, in order for these two equations to be equal, their exponents also have to be equal. So 2x has to equal 6 in this case, which means that x has to be 3. And so that's another kind of property is if the bases are the same, then the exponents have to be equal. So if you have something to a power equals something to a power, and those two bases match, then the two powers have to be equal, all right? They have to be equal. So we're going to use this property to solve a little bit here. So we have used the like basis property to solve the equation. 5 to the power of n equals 125. Well, right now we have 5 and 125, so we don't have like bases. But what we can do is we can edit the 125 and we can make an adjustment so that it is 5 to a power. And so 5 to what power is 125? That is 5 to the power of 3. And if you're not sure, you can use your calculator, right? 5 squared, 5 cubed, 5 to the 4th to figure out the appropriate number. And that's equal to 5n. And so now that our bases are the same, it's very easy to conclude that n has to be equal to 3 in order for that to happen. All right, use like basis property to solve the equation. So we have 1/2 to the n equals 32. And 32, we're looking to change it to a 1/2 base. So 1/2 to what power is 32? Because this is a 1/2, I'm automatically thinking that I'm going to need a negative number in my exponent. So you can type in 1/2 and start raising it to the powers. If you were to start with your positives, you would get 0.25 to the third, you would get 0.125. And so in the positives, you're kind of seeing that you're not getting anywhere close to 32. So you can go with the negatives. -2 gives you 4. -3 gives you 8. So we're headed the right direction. -4 would give you 16, which makes -5, 32. And that's because 2 to the power of 5 is 32. So if you have a fraction, it's the negative of that. Just like when we were talking about exponentials, when we were graphing them, how those negative exponents work, we're using them here as well. So 32, we can get rid of it and we can edit it essentially to say 1/2 to the -5th power. So 1/2 to the n over here. So because the bases are now the same, we know that n has to be equal to -5. So I'm going to make an adjustment and see if I can get this better. There we go. All right. So as you're working these, it's always figure out what you need to do to get the same base. Once you have the same base, you can set those exponents equal to each other and solve away. All right. So here we go. We have 10 to the power of n plus 3 equals 10 to the power of 8n plus 5. And the nice thing here is I have base 10, base 10. So my bases already match, which means that those two exponents have to be equal. So we're going to say n plus 3 equals 8n plus 5. And then just use your Algebra 1 skills to solve this. So subtract the n, that would be 7n over here. Subtract the 5 would be negative 2 on this side. So n is negative 2 over 7. So you're not always going to have nice values here for n, right? You could have fractions, you could have decimals, all that fun stuff. All right, we have a few more examples in this with using the same property to solve. So here's the next one. We have 1 over 10, and then over here we have a base of 10. And so it doesn't matter if you make them both 1 over 10 or if you make them both 10. It's completely up to you. You probably might want to lean more towards making them not fractions, but for this, it really doesn't matter one way or the other. So I'm going to change this 1 over 10, to a power or to a base of 10. And so to go from 1 over 10 to a base of 10, that had to be to the power of negative 1. And if you already have a power up there, those two powers will be multiplied together. So you can change this 1 over 10 to the power of x minus 6 to 10 to the power of negative 1 times x minus 6, because this 10 to the negative first is the 1 over 10. All right, and it's equal to 10 to the power of 5x plus 8. And so we're going to go ahead and say, all right, now my bases are equal, so my exponents have to be equal. So the hardest part with solving these is going to be figuring out how to get those bases the same and what you have to do to change the exponent so that you can get the bases the same. All right, so here we have negative 1 times x minus 6 will be equal to 5x plus 8. And this equation shouldn't be too hard for you to solve, right? Distribute the negative 1, combine like terms, so that'll be 6x over here and a minus 2 on this side. So x would be negative 2 over 6, which simplifies to negative 1 over 3. So the solving here is not what I'm expecting to give you a hard time. What should give you the hard time or be the hardest for you is trying to get those bases to match there. All right, so we have one more like this. And this one looks really interesting because you don't just have something to a power equals something to a power. You actually have a multiplication happening in here. And so the goal is to get all of these to be the same base. So we have 5, 25, and 125, and we all want them to be the same base. Hopefully it's jumping out to you that this is 5 squared and 5 cubed. And so the goal is to get them to all base 5. So the first one is fine because it's already base 5. So nothing needs to change with that. The second one does have to change. In order to go to base 5, it's going to need a square, right? 5 squared is 25. So base 5, but now there's an extra 2 in the exponent that is being multiplied by our current exponent. And then that's going to be equal to, and then this 125 is 5 to the power of 3. So that current exponent, the 4x plus 9, also has to be multiplied by 3 to get all of these bases to be the same. All right, we talked about this briefly in the last video. If you have two bases that are the same being multiplied, what do you do with your exponents? This is an Algebra 1, rules of exponents. You can add them. The two exponents get added. So you can say this is 5 to the negative 8x minus 1 plus 2 times 2x plus 3. So you can change it into one base with your exponents being added because they were being multiplied. And then this side, I'm just not going to change. So now you have two bases that are exactly the same, which means their exponents have to be equal. So we have negative 8x minus 1 plus 2 times 2x plus 3 has to equal 3 times 4x plus 9. And that is an equation that I think you should be able to solve at this point. You could have distributed, by the way, at any point. If you want to distribute as you wrote this and as you wrote this, that's fine with me. But then this way, at least you can see where all those pieces ended up. So at this point, you would go ahead and distribute. And then from there, combine like terms. And then from there, you should get what x will equal. So I'll finish this for you. Negative 8x minus 1 plus 4x plus 6 equals 12x plus 27. Moving all the x's over here to this side, because I think that'll keep them all positive, this would be 20 and then minus 4, so 16x over here. We have 5, and then subtracting that over would be negative 22. So x is negative 22 over 16, which simplifies, they can both divide by 2, so negative 11 over 8. So there's your x value, negative 11 over 8. And I don't expect this, like I said before, I don't expect this to be the hard part. This is the Algebra 1 solving, right? The hard part is going to get those 5s to have the same base and have them equal to each other so that you can go ahead and use that property that says the exponents are equal. So this is probably where you're going to see the most struggle. So as you're working on homework problems for this question, it's going to be really helpful if you have a question to shoot me a picture of this part so that I can see if you even got them to be equal before you even moved on. Most likely you won't make much of a mistake here, but you would up here. All right, so we're going to continue to solving some exponentials, but in this case, these exponentials, we don't have a shot of having the bases being equal to each other. So this says find the solution of the exponential equation e to the power of 3x minus 5 equals 2. And this e and 2, it's not possible, unfortunately, for us to make these the same base. And so because it's not possible for them to be the same base, then we're going to have another method of solving here. And so the other method of solving here is actually to use the opposite of an exponential. And the opposite of an exponential is a logarithm. Remember that? Opposite, exponential, logarithm, they're inverses of each other. And so what we're going to do is we're going to solve this by undoing the exponential by using logarithms. So here's our equation, e to the 3x minus 5 equals 2. And the first thing that we're going to do is we're going to put in a logarithm here. Because it's base e, I'm going to use the natural log instead of the regular log because of that base right there, okay? So you can take the natural log of this side as long as you take the natural log of the other side at the same time. So it follows the rule, what you do to one side, you have to do to the other. In this case, what we're doing is we're natural logging both sides. We're taking an operation there, a value, a natural log value there. So what's going to happen over here is really quite interesting. You have a power and you have a natural log, which means you can use the power rule. So that 3x minus 5 is going to come down in front of the ln of e. And we've talked about before what the ln of e equals. It is equal to 1. And so ln of e being 1 means that this is just 3x minus 5 times 1. So that is just 3x minus 5. On the other side of the equation, you have the ln of 2. And if you want to try it in your calculator, you can. Ln of 2 is a decimal. And so because it's a decimal, we're going to be leaving it as the ln of 2. Our question is asking for an exact solution, which means you don't change it to a decimal. And then it is asking for an approximate, which means we'll take this one and put it in a decimal at the end. So right now, we're not going to be changing anything to decimals. So this is equal to the ln of 2. All right, and you solve this just like you would solve a two-step Algebra 1 equation. You're trying to solve for x, so you would add 5 and then divide by 3. So adding 5, I like to put it in the front and say 5 plus the ln of 2. And then divide by 3 means you would divide this whole thing by 3. So x is 5 plus the ln of 2 all over 3. And that is your exact solution. So this would be 5 plus the ln of 2. Make sure that you put this in a fraction so that you can get it all over 3, not just one of them. Put both of them over 3. And then for the decimal equivalent approximate solution correct to 4 decimal places, you're just going to type this into your calculator. And I'm going to do it in 2 parts. I'm going to do 5 plus the ln of 2, and I'm going to hit enter. And then I'm just going to hit divide by 3, and it will take my answer divided by 3. And it says correct to 4 decimal points. So that is here. And so that would round down, so that would stay the 7. So it's 1.8977, correct to 4 decimal points. If you try to approximate here or here or here at some point with the ln, when you do this final calculation, you will be off. So don't do this part until after you have the entire exact solution, then you just type this in. All right. Next question is almost identical. It says the same thing. Solve the equation. Give the exact answer using the log function and an approximate solution to 4 decimal points. So once again, x equals, that's going to be the exact. X is approximately, that will be your decimals. So here is your equation. E to the 4x plus 4 equals 41. And so eventually we're going to take care of this exponent and get the x out of the exponent. But before we do that, it actually makes a lot of sense to just move the 4 over. So the first step is to go ahead and get rid of that 4. So subtract 4, you would end up with 37. And then what we're going to do here is we're going to go ahead and take the natural log of both sides because this is base e. So we'll natural log both sides in order to get that power out of the exponent. We'll bring the power down. So ln of both sides. And when we do that, the 4x can come into the front. So this would be 4x ln of e. And we talked about the ln of e is just equal to 1. So it'd be 4x times 1, which is just 4x. And that is equal to this side, which is the ln of 37. And if you wanted to type it in your calculator to see if it was a nice number, you could. By the way, you're not going to get nice numbers. I'm just going to point those out. So not a great number. And so this will be our exact solution, continuing with the ln of 37. And then the last step is to divide by 4. So x would be the ln of 37 all divided by 4. So exact answer, ln of 37 all over 4. Make sure that you don't say ln of 37 over 4. Sorry, you can't see that. Make sure you don't say this, ln of 37 over 4, because what the system, your calculator or whatever is going to think is that you want to do 37 divided by 4 first and then take the natural log. When in fact, we want to take the natural log value first and then divide by 4. So just be extra careful there on how you set that up. If you can get them into fractions in My Open Math, that will help make sure that you don't mess up where values are supposed to go. All right, and then for the exact solution, you can type that in your calculator, ln 37, close the parentheses before you hit the divide by 4, or you can type in ln of 37, hit enter, and then divide by 4. So we get 0.9027, so there's our 4 decimal places right here, and then the 2 would just keep that as a 7. It would make it round down. So 0.9027. All right. These ones are a little bit harder to solve because of that natural log in terms of like doing the operation there. It's kind of a new operation that you've never seen before. So we have some more examples. I think I have 4 more for you. And then you'll be free to finish this homework section. So these are all My Open Math examples. So the next one, you can't really see it. It actually says 4 to the power of x minus 4 equal to 9. And so we're going to solve this equation. There's nothing to add or subtract at the beginning because there's no constants, right? Messing around here. So we're going to go ahead and just take the natural log of both sides. I like to just always stick with the natural log. You could log both sides, but natural log works and it's one less letter. So I roll with the natural log. Which means when you do the natural log over here, you can use the power rule. And this would be x minus 4 times the natural log of 4 equals the natural log of 9. And the downside here is we don't have an e, so this natural log of 4 is an actual value that we can't get rid of. It's not like the natural log of e where it's just 1 and it goes away. That is a number there. And so we do have to include it in our solution, all right? And once again, we're finding an exact solution and then an approximate solution as well. So solving for x, your brain might say go ahead and distribute, which is fine. You could distribute. But what this really is x minus 4 times the ln of 4. And so what you can do is you can actually just go ahead and divide by the ln of 4. And that's going to get these to go away. So you're just x minus 4 on this side. And then if you want to type this in your calculator, you can to see if it simplifies. But I'm going to tell you that it's not. It's just ln of 9 divided by ln of 4. And it doesn't simplify into one natural log. This is not a property in any capacity. All right, and last but not least, if you're solving for x, you get rid of the 4 by adding 4. So it would be x equals the ln of 9 over the ln of 4 plus 4. And so that is your exact solution. Ln of 9 divided by ln of 4 plus 4. All right, for the approximate solution, you can go ahead and type that into your calculator. So it'd be the ln of 9, make sure you close the parentheses, divided by the ln of 4, make sure you close parentheses if you're going to do it all at once. And then you can either hit enter right now and get a number, or you can just say plus 4 at this moment because we've closed all of our parentheses in the right spots. So we have 5.5894, and then here's the fourth decimal point, and it's a 6 after, so this is going to round up, and the 49 will round up to a 50. So 5.5850. All right, up next is the same type of question, but there's a lot more numbers going on here. So we're going to write the exact solution, and then we're going to round to 4 decimal points. So here's your equation, 19 minus 20, parentheses 1.01 to the power of t equals negative 131. And so imagine that this whole thing right here was just a variable by itself. You could go ahead and get rid of the 19 and get rid of the 20 by subtracting and dividing, right? So it's actually in your best interest to go ahead and do that now. So subtract 19 from both sides and divide by 20 will leave you with, I have 7.5. Let's check just to make sure. Negative 131 minus 19 divided by a negative 20 is 7.5. So just by doing a little bit of algebra, combining like terms at the beginning, the 19 and the 20 both can go over, leaving you a 7.5. And then this will be much easier to work with. Whenever your variable is in the exponent, that's the hint to you that you're going to have to take the natural log of both sides. So you can ln this side and ln this side, natural log them. And when you do that, that power will come to the front. So the t is no longer in the exponent. It is now just a normal, regular t. All right. You also don't have to put these parentheses anymore around that number since it's just a single value there. And last but not least, to get t by itself, you want to get rid of this natural log. So you just divide it. So it would be the ln of 7.5 over the ln of 1.01. And that's going to be your exact solution. 1.01. And then for the decimal, you're just going to type this into your calculator. So ln of 7.5, make sure you close the parentheses, right? Divided by the ln of 1.01. You can close these ones. It really doesn't matter since we're just going to hit enter. So I have 202, and then it says 4 decimal points. So that would go to the 0. The 8 would round the 0 up to a 1. So rounded is 202.4961. All right. These last two problems are going to be significantly harder than what you've seen so far. So if you're kind of struggling, you're kind of barely hanging on, I would suggest that you go ahead and pause right now, go work on My Open Math, work on those questions, get more familiar with this concept of natural logs and solving, and then if you get all those done, come back and watch these last two, okay? So that's what's highly suggested. So what I'm actually going to what I'll actually do to make it easy is I'll stop this recording and I'll just do a part 2 where it's just the last two problems. So if you've made it this far and you want to take a break to go work on My Open Math, highly suggested. These last two are very heavy on the natural logs. All right, there's just a lot more going on. So if you don't feel confident watching them right now, that's fine. Just hit pause, go work on your other ones, and come back. All right.